Hi everyone, welcome to Hands-on DevRel again. I'm going to be continuing to build the Hedera Developer Course, Module 101, 02, which is querying Hedera Network State. And this is part of a spike. So the spike is just a minimal subset on which we can get feedback. So what I'm going to do now is record myself running through the slides. And I know that the slides are not in the final state just yet, but this is an iterative process. So that's the idea, right? So recording myself and watching my own recording and also giving it over to my colleague who will also review the video and then have some ideas, joke some ideas, suggestions, etc. on how to improve the video. Like, oh, this slide should have more words or less words, or maybe here's the picture that we should put in, here's an animation we should put in, etc. Right? So that's the purpose of this session. So let's begin. So I'm gonna present with presenter view, right? And I'm going to, instead of hiding this in my secondary screen, etc., I am going to simply put this like so, right? And then I'm just going to check that I can see my speaker notes. Yep. Okay, that works for me. A little bit bigger. All right. So then the final recording should only just have this section in here, right? But for now, it's going to include all of this trim so that we can see what's going on behind the scenes, so that you can see what's going on behind the scenes. Hands-on DevRel, we're building in public. All right, let's begin. Welcome to the next module of the Hedera Developer Course. This one is about querying Hedera Network State. So within this module, we'll have a couple of explainer videos about what is blockchain state, CQRS, as well as 3 labs. And finally, we'll end off with a recap. Each of the 3 labs are just different ways in which we can query the Hedera network. Let's begin with blockchain state. State refers to data that is stored on some computer system. On computer systems with distributed or decentralized architectures, various computers may agree or disagree on what the correct data is. Therefore, in these systems, state includes an additional requirement, which is that state is not just what data is recorded on the system. Also, it's additionally what other computers in the system agree is correct. Once a computer system has state stored in it, the simplest thing you can do with that is to query it. Here's the flow. Send a request, then receive a response. It's like a question and answer. This entire operation, importantly, should result in no state change. In other words, the state before the query and the state after the query should be identical. More complex than querying is updating. When you update state, the state before the query and the state after the query can be different. Some portion of the state is added, deleted, or modified. To do this, just like a query, you make a request, then receive a response. However, unlike a query, you're expecting there to be a side effect, the change in the state. So far, we've talked about generic computer systems. Now let's address blockchains more specifically. When you want to perform a state change in a blockchain, you do so using a transaction. A transaction is a type of message that encapsulates the intended state update of the blockchain, as well as any additional information needed for it to be considered valid. This additional information is called transaction metadata, and a cryptographic signature is a crucial part of this. This additional information is called transaction metadata, and a cryptographic signature is a crucial part of this. When a transaction is submitted to a network, all blockchain nodes receive a copy. Each node then verifies if the state change in the transaction is valid, and each node also verifies if the transaction metadata is valid too, including performing public key cryptography to verify if the transaction has been signed by the correct account. If both verifications pass, the blockchain can update its state with the transaction data. Let's circle back to that what is state question from the beginning, but this time let's ask, what is state in blockchains? As we learned before, State is data that has been agreed upon by computers in the network. In blockchains, that refers to the blockchain nodes being in agreement with each other. What they agree upon are the transactions. Think of transactions as agreed upon transitions from the previous state to the next state. The way that blockchain nodes agree with each other is through a consensus algorithm. There are many of them out there, such as proof of work and proof of stake, but we won't go into detail in this module. Let's shift gears a little and talk about transports and protocols, as these are related to requests and responses. These are what computer systems use to communicate, and there are many of them. This is especially true in blockchains, since multiple nodes need to communicate with each other to achieve consensus on transactions. But how exactly do they talk to each other? Transports define the method of communication between one computer and the next, specifically how messages are transmitted. HTTP, WebSockets, gRPC, and SSH are some common transports used by computers to move information between each other. Protocols are more specific to the applications which use them. These are more to do with exactly how the data is arranged or serialized when it's being transmitted between one computer and the next. JSON RPC, protocol buffers, XML, and even plain text are common formats. Transports and protocols are commonly used together. For example, web browsers can use XML, which is the protocol, over HTTP, which is a transport. In blockchains, JSON RPC can be used over both HTTP and WebSockets. You can also use protocol buffers over gRPC, which is something that Hedera uses in addition to JSON RPC. And that's a wrap of blockchain state. Alright, so I've now recorded the video, and my next step is to watch my own recording.